Welcome to doassignment-ca. Here is the problem. A particle moves along a straight line with an acceleration of a equals 5 divided by the quantity 3 times s to the 1/3 power plus s to the 5/2 power in meters per second squared, where s is in meters. Determine the particle's velocity when s equals 2 meters, given that it starts from rest when s equals 1 meter. Use a numerical method to evaluate the integral. Now, let us work through the solution step by step. For straight line motion, acceleration equals v times dv ds. This lets us separate variables and integrate since acceleration is given as a function of position. Substituting the given acceleration into a ds equals v dv, then integrating both sides. The right side evaluates to 1/2 v final squared. The left side is the integral from s equals 1 to s equals 2 of 5 over the quantity 3s to the 1/3 plus s to the 5/2 ds. We define the integrand f of s and apply Simpson's 1/3 rule using 4 subintervals. The step size h is 0.25 meters, giving 5 equally spaced nodes to 2 point. We evaluate the integrand at each of the 5 nodes. At s equals 1.0, f is 1.2500. At s equals 1.25, f is about 1.00641. At s equals 1.52, f is 0.8820. At s equals 1.75, f is 0.64944. And at s equals 2.00, f is 0.52812. Applying Simpson's rule, multiply h over 3 by the weighted sum of the function values. Endpoints get weight 1, the interior midpoint gets weight 2, and the remaining nodes get weight 4. The bracket sums to about 10.018, and multiplying by 0.25 over 3 gives approximately 0.8348 meters squared per second squared. Setting 1/2 v final squared equal to the integral result of 0.8348, we solve v final squared equals 1.6697, and taking the square root gives v final approximately equal to 1.292 meters per second. As a check, the integrand is positive and decreasing over the interval, and since the particle starts from rest and accelerates, a positive velocity is expected. Using Simpson's 1/3 rule with 4 subintervals, the velocity at s equals 2 meters is approximately 1.29 meters per second. Visit doassignment.ca for more study tools, AI learning support, and online tutoring.